Hi friends, in this video we are going to discuss about the concept of resonance. So first we are going to discuss about what is resonance, and after that how we are going to get the resonance in the series RLC circuit, and after that where we are going to use the concept of resonance in the application, and the last thing is what is the frequency at which the resonance occurred. Okay, so for all these questions we have a solution in this video. Now anyway, first we are going to start with the concept of what is resonance. Okay, what is resonance? Now see here, so this is also one of the most important definition of the resonance. Now see here, when a light or a sound wave strikes an object that is already vibrating at some particular frequency, and if that frequency happens to match the frequency of the object which is hitting, then is called as what? Then it is called as the condition of resonance. Okay, or we can also call it as the resonance. For example, see, this is one object. For example, this is one object. For example, this is what? This is, for example, one light wave. Okay, for example, this is one light wave, and this light wave is directly hitting on this particular object, for example. Okay, now we know that for every object having some frequency. Okay, for example, what I am telling you, this f is the f, otherwise you can take fo is the frequency of object, and here fl represents the frequency of light. Now see here, whenever the light wave strikes on the object, and this object is already vibrating at some frequency, that is f0, then if that frequency f0 happens to match with the frequency of the light, then that particular condition we are calling as resonance. Okay, so this is the definition of resonance. Okay, so whenever light or a sound wave strikes an object that is already vibrating at some particular frequency, and if that frequency happens to match the frequency of the object it's hitting, then you will get what is called as the concept of what? Resonance. Now this is the concept of actually resonance. Now coming to the resonance in series RLC circuit. Okay, we know that we are having so many combination like series RL, series RC, series RLC. Okay, now we know that how we are going to get the resonance in the electrical circuit, that too in the series RLC circuit. Okay, for example, see here, for example, I am going to consider one series RLC circuit like this, for example. Okay, now for example, this is the value of R, this is the value of inductive reactance, and this is the value of capacitive reactance, and this is the applied voltage. Now in any series RLC circuit, the resonance is always occurred in series RLC circuit when the value of XL and XC both are equal. Okay, it means what? In the series RLC circuit, resonance will occur when the value of inductive reactance is equal to capacitive reactance. When these both values are equal, when both the values are equal in the series RLC circuit, then that particular condition we are calling as resonance condition. Okay, and we know that what is the expression of impedance? Actually, the expression of impedance is equal to Z is equal to R plus J into XL minus XC. So under resonant condition, XL is equal to XC means, so at the time of resonance, the value of impedance Z is equal to R, because what? XL value, XC value both are equal means, then XL minus XL, if I am writing, then positive XL, negative XL both are gets cancelled means you will get what? Z is equal to R ohms. That is the reason why at the time of resonance in series RLC circuit, the impedance is equal to, the impedance Z is equal to resistance. That is the reason why at the time of resonance we are calling as the circuit will act as a pure resistive circuit. That is the reason why for pure resistive circuit, the phase angle between the voltage and current is always what? 0. Because in case of pure resistive circuit, so voltage wave and current wave, voltage waveform and current waveform, or voltage sinusoidal wave and current sinusoidal wave, both are in phase. That is the reason why. So phase angle between these two must be 0 at the time of resonance in the series RLC circuit. Okay. Now this is clear. So at the time of occurrence of resonance in series RL circuit, XL is equal to XC. That is clear. But another concept, that is, what is the value of what? What is the value of frequency at the time of resonance? So that is the reason why the frequency at which the resonance occurred, okay, the frequency at which the resonance occurred is called as resonance frequency. Okasari chudandi, just see once. Resonance frequency. Resonance frequency. What is the definition of resonance frequency? Means simple. The frequency at which the resonance occurred is called as resonance frequency. Okay, and this resonance frequency is always represented with FR. Okay, so FR is a representation of what? Resonance frequency. And here, if you want to find the resonance frequency at the time of occurrence of resonance in the series RLC circuit, how we are going to calculate the value of resonance? Means simple. We know that when we are getting resonance, actually when XL is equal to XC, okay, when XL is equal to XC, then only the resonance occurred in a series RL circuit. That is the reason why XL is equal to XC. With the help of this particular expression, we will get the expression of resonance frequency. Now we know that XL is equal to omega L, and here omega means 2 into pi into f, and here L is always L. Now XL, this is XL. Now coming to XC, XC is equal to 1 by omega C. Now we know that 1 by omega means what? 2 into pi into f into C. So that is the reason why. Just substitute this value and substitute this value in this expression, you will get what? So 2 into pi into f into L, that is equal to 1 divided by 2 into pi into f into C. Now just substitute, instead of f you can substitute FR, because FR represents the resonance frequency. So that is the reason why 2 into pi into FR into L is equal to 1 divided by, so 2 into pi into FR into C. Now from this we can write, here FR is there and here FR is there. So if I am going to writing the expression for FR square, you will get what? So here you will get 2 into pi into C into 2 into pi into L. If I am going to simplify this one, you will get 1 divided by, so 4 pi square L into C. Now this is expression of what? FR square. If I am going to write the expression of FR, you will get what? 1 divided by 2 into pi into under root LC, and this is always in hertz. Okay, so this particular expression represents the resonance frequency. Okay, so this particular frequency is occurring in a series RLC circuit when the resonance is occurred in a circuit. And in order to get this expression of FR, we need to consider the expression, that is XL is equal to XC. With the help of this expression, we are going to get the expression of FR. Okay, so this is the calculation of FR. Now coming to actually where we are using this concept, where we are using the concept of resonance, means the concept of resonance is highly useful in the design of basic filtering circuits for use in everyday application, such as what? and audio amplifiers. Okay, the concept of resonance is highly useful in the design of basic filtering circuits for use in everyday applications such as an audio amplifier. Okay, so this is the concept of resonance. So first thing is what is resonance. Next thing is when we are going to get the resonance in the series RL circuit, and what is the frequency of resonance, and that is the definition of resonance, resonant frequency. So, and where we are using the concept of resonant means in case of what? Audio amplifier. So this is about the concept of resonance, and which is very, very important. Thank you so much for watching, and please do subscribe my channel for more updates.